All right. Good afternoon, chemistry class. This is Coach Jeans, and in today's video, we're going to talk about balancing chemical equations. Now, when you have a chemical reaction, we represent it with a chemical equation, which is a group of symbols and subscripts that represent each compound and other symbols. And so, what we have to do in chemistry is we have to make sure that we have the same numbers of every atom or polyion on both sides of the equation. Now, this demonstrates a fundamental law of chemistry, and that's the law of the conservation of mass. Basically, what that says is that mass cannot be created or destroyed, or matter cannot be created or destroyed. So you have to have the same numbers of each kind of atom on both sides of the equation. So when we write these down in formula equations, we have to demonstrate and obey the law of conservation of matter. And how do we do this? Well, we do this by changing only the coefficients. We're not going to change the formulas. Once a formula has been written, the subscript in the formula stays the same. Remember an ionic formula that the subscript is there so that the charges on the cation and the anion cancel out and they equal up to zero. Herbert, yes, please. All right. So you can tell that I'm still here at the school, and they're trying to announce something here. But anyway, so make sure that you don't change the formulas. The formulas will always stay the same. Once the formula is written correctly, do not try to change subscripts in order to balance equations. Only thing we're going to change are coefficients. So we'll take a look at several examples of these. All right, so you want to jot this down on your notebook paper as we go through these, and pause the video as needed. Make sure you follow along, rewind if you have to. All right, so here's some examples of balancing chemical equations. So first one we have is CH4, which is methane, plus oxygen gas, which yields carbon dioxide plus H2O. So we have, this would be natural gas reacting with oxygen in a combustion reaction. So what we need to do is we need to see, do we have the same kinds of atoms and numbers of each kind of atom on both sides of the equation? So here's our yield sign, or our produces sign there, and we need to check this out. So we have carbon. We have carbon on the left side. We have only one of them. Remember, if there's no subscript, it's understood to be one. One carbon on the left, one carbon on the right. So we're good there. Hydrogen. Well, on hydrogen, we have 4. But on the right, we have 2. So what we're going to do, I'm going to put little spaces in here. We're going to put coefficients in front of the compounds. Now, coefficients are just like in math. They multiply. They're numbers that multiply. So if I want to get 4 hydrogens, what I'm going to do is I'm going to place the coefficient of a 2 in front of the H2O. Kind of made that a little crowded there. Sorry about that. But 2 times 2 is 4 hydrogens. And so we have 4 over here, and we have 4 on the right-hand side. So we're good with that. Now we're going to take a look at our oxygen. We have 2 here. Now on the right-hand side, we have 2 of them in this compound, plus we have 2 times 1. These multiply, so the 2 times 1 gives you 2 oxygens in this compound. So 2 and 2 makes 4 on the right side, 4 oxygens. So what we're going to do is we're going to then multiply by 2. 2 times 2 gives me 4 oxygens on the right. So now it's balanced. Now you say, well, what about these blanks in front? Well, if you want to, you could put a 1 in front of that, all right? But it's usually left blank. 1s are usually understood, so I'm going to leave them blank. But if you put 1s on yours, I'm not going to dock you for points or anything like that. All right, let's take a look at the next one. Let's say we have calcium plus nitrogen gas, which is N2, and it's going to yield Ca3N2. All right. Now remember, these subscripts are placed there because this is a brand new formula, and so it's there so that your charge is balanced and the compound's net charge is 0. It doesn't have anything to do with the subscripts over here. All right, so we're going to count those up. On the left side, we have 1 calcium. On the right side, we have 3. So we're going to multiply 3 times 1 gives me 3 calciums on the right. So now that was taken care of. We already have 2 nitrogens on the left, and we have 2 nitrogens on the right-hand side. So that one's taken care of. All right, let's do another example. Let's do KClO3 plus, or excuse me, that should just be yields or produces, KCl plus O2. All right, so we're going to take a look at this one. We have 1 potassium on the left, 1 potassium on the right. We have 1 chlorine on the left, 1 chlorine on the right. We have 3 oxygens on the left and 2 on the right. So we got a little issue there. Now we look at this, there's nothing I can multiply by 2 that's going to give me 3. So what I need to do is I need to find, you might want to write a little note about this, find the least common multiple, all right? Just like we do a lot of times in math, okay? We need to find the least common multiple, especially when you're dealing with fractions and all those fun things like that. Well, what is the least common multiple between 2 and 3? Well, obviously, it's 6, right? So what do we multiply 2 by to get 6? 3. So we put a coefficient of a 3 there. 3 times 2 is 6 oxygens. Now, what do we multiply 2 by to get, or excuse me, 3 by to get 6? Well, of course, it's 2. Now, I can't place the 2 in the middle here. I can't break the formula up. The coefficients have to go in front of the formula. So the only place I can put it is right here in front of the formula. So 2 times 3 is 6, no problem. However, this does change my potassiums and my chlorines because it's multiplied by everything that it's in front of. So 2 times 1 is 2, so I have 2 potassiums on the left. I only have 1 over here, so I need to put a coefficient of a 2 here. 2 times 1 gives me 2 potassiums. 2 times 1 gives me 2 chlorines, and 2 times 1 gives me 2 chlorines. So now everything is balanced out. Let's do another example. Let's do Na plus Br2 is going to produce NaBr. So we look at this one. We've got 1 Na on the left, 1 Na on the right. We've got 2 Brs on the left. We only have 1 on the right. Now, some people say, well, why can't you just come in here and put a 2 right there? Well, see, if you did that, that changes the entire formula. And now this formula is not written correctly. So you can't do that, all right? So make sure you don't do that. You can only change coefficients. So the only thing that I can do is put the 2 in front. Now 2 times 1 gives me 2 bromines, but this also changed my sodiums. So I come back and I put a 2 right there, and that'll take care of the sodium. All right, let's go ahead. Let's do Fe2O3 plus H2SO4 produces Fe2SO4 in parentheses with a 3 on the outside. Make sure you're putting the formulas correctly, plus H2O. All right, so we take a look at this one. Let's start with our Fe, our iron. We have 2 on the left, we have 2 on the right, so we're good there. Now I'm going to leave hydrogen and oxygen to the end. So I'm going to skip this oxygen for now. All right, and then I'm going to come over here and I'm going to skip this hydrogen for now. Now what I'm going to deal with is my sulfate. Now notice we have an SO4, that's known as sulfate, right? We have it on the left side and we have it over here on the right side as well. Okay, so I'm going to go ahead and just use a green pen here just to kind of show the distinguishing. I'm going to put a parentheses there just to indicate or just to kind of isolate my SO4, my sulfate. Well, how many sulfates are represented here on the left? Well, it's understood to be a 1 on the outside. So that's just 1 sulfate. Okay, now the SO and 4 stays together and we treat it like 1 unit, sulfate. So there's only 1 of those. On the right side, there's 3 of those. So if I place the coefficient 3 in front of the formula, 3 times 1 gives me 3 sulfates, and that equals my 3 sulfates on the right. You say, well, that has oxygen. Yes, we're going to come back to this oxygen by itself and deal with it, but we've taken care of the sulfate unit now, okay? So now let's take a look at our hydrogen next, working our stuff kind of backwards. 3 times 2 is 6. So what can I do on this side? Well, place a 3 here. 3 times 2 is 6 hydrogens. Now, what about my oxygens? 3 on the left-hand side here, and 3 times 1 is 3 on the right-hand side. So that took care of itself. So usually what I do is I always leave my hydrogen and oxygen to the last. And usually things work itself out. And I do know some other people, they do it the opposite way, and they always do their oxygen, and it works for them, and that's fine with me as well. But the main thing is when you get to the end that you have a correctly balanced chemical equation. All right, let's do some more. Let's say NH4 parentheses 2 and CO3 on the outside. So you have ammonium carbonate, and this. Sorry about that. This is supposed to be a arrow, a yield sign, and it forms NH3 plus CO2 plus H2O. So it forms 3 products here. Okay. When we look at this one, you said we've got polyions. That's correct. But you don't have the same polyion on the right. So you're going to have to break this one up, all right? Now, when you have parentheses and a subscript on the outside, it multiplies by the atoms on the inside. So nitrogen, this 1 on the inside, times 2 gives you 2 nitrogens. Well, how many do I have on the right? I only have 1. So I place a coefficient of a 2 right here. 2 times 1 is 2 nitrogen, so that takes care of that. Now we're going to skip hydrogen and oxygen. We're going to go to carbon. Carbon, I have 1 carbon here and 1 carbon there, so we're good there. Now let's deal with our hydrogens. 4 times 2 is 8. Come over here. 2 times 3 is 6. But remember, I've got another 2 hydrogens here. So 6 plus 2 gives me 8 hydrogens, okay? All right, everybody see that? 2 times 3 is 6, plus the 2 hydrogen there gives me 8. Now let's deal with our oxygens. We have 3 here. On the right side, we have 2 in this compound, plus the 1 here gives me a total of 3. So this one is now correctly balanced. All right, let's try another one. Let's do let me start over with this one. Let's go C2H6 plus O2 produces CO2 plus H2O. All right, this will be an interesting one. All right, so we start out with carbon. We've got 2 on the left and only 1 on the right. So let's go ahead and place a 2 right here. Now, it may be a good idea to use pencil, not use pen like I am, because sometimes you do have to go back and erase. You'll see what I mean. But for right now, if you're using pen, you'll just have to do it the way I am. So this is a 2 right here, okay? So 2 carbons. Now let's look at our hydrogen. 6 hydrogens here. We only have 2 there. So 3 times 2 gives me 6 hydrogens. All right, we're doing well. 2 oxygens here. How many do we have on the right? 2 times 2 is 4, plus 3 is 7. Well, what can we multiply 2 by to get 7 oxygens? Well, you could multiply by 3.5, right? However, we don't like to have decimals, okay? So you might want to jot yourself a little note like that. We don't like decimals as coefficients. So what we need to do is multiply each by 2. All right? So since we don't like decimals, if I go back and I multiply each coefficient by 2, let's see what that does. So this is understood to be a 1. So 2 times 1 is 2. 3.5 times 2 gives me what? 7. 2 times 2 gives me 4. And 2 times 3 gives me 6. Now let's check it. Let's do our carbons. 2 times 2 is 4 carbons. 4 times 1 is 4 carbons. 2 times 6 is 12 hydrogens. 6 times 2 is 12 hydrogens. 7 times 2 gives me 14 oxygens. 4 times 2 gives me 8 oxygens. And then we have the 6 times 1. That gives me 14 as well. So as you can see here, it balances out the chemical equation.
Please come to the front office. Corporate Gaines, please come to the front office.
All right, sorry about that. As you can see here, we have 14 oxygens on both sides of the equation. So the equation is balanced. All right, so I'll see you in class. We're going to do a lot of examples in class, give you a chance to practice, and I hope this video really helps you out.